Hello students! So this video here is about solving quadratic equations using square roots. For those who may be looking at the word square roots, and I'm sure most of you, if not all of you, recognize what square roots are. But square roots are pretty much the most basic type of radical. And so remember, a radical is something that looks like this, and up under a radical you will have the thing that you're actually taking the square root of, and that thing that you're taking the square root of is called a radicand. Just a little bit of background here before we actually look into solving these things. I'm pretty sure that most of you know this already about square roots, but again, you take the square root of the radicand. For a square root, again, it's the most basic type of radical. For a square root, the little tiny number that's on the outside, on the left side, on the outside of a radical, is a 2. Many times that 2, or what we call the index of a radical, a lot of times that 2 is not written for a square root. But for a square root, again, that is the only type of radical where the index is not written. So when we are asked to take the square root of a number, what it's really asking you is asking you to find a number that is multiplied by itself that will give you the result of I guess that will give you that result of the radicand. So again, like if you were asked to find the square root of 16, for example, they'd really be asking you to find some number that when you multiply it by itself, it would give you 16. Okay. So again, folks, that's just a little bit of background information about square roots. Again, some of those technical terms like index, radicand, and radical sign. And we're just going through some of that basic vocabulary so that in the future, if we mention words like radical or radicand, you know what I'm talking about. You know what we're referring to. And so let's say that you're trying to find the square root of a number. A lot of times, most of you will probably be using a calculator when you're doing this. But again, we just kind of want to bring up one quick point. Whenever you're finding the square root of a number, there are usually 2 possibilities that you could have when you're trying to find the square root of a number. And so let's just look at, for example, the square root of 16. So if we're looking at the square root of 16, I know that most of us either know already what the square root of 16 is, but if not, then you can use a calculator. Again, we're talking about finding the square root, meaning that we're really talking about finding some number that when you multiply it by itself, you would get 16. So some number multiplied times itself gives you 16. Most of us would automatically say, okay, 4. The square root of 16, Mr. Starkey, is 4. Because you can take 4 and multiply it by itself, 4 times 4, and you would get 16. If you said 4, you are correct, at least halfway. 4 is one of the square roots of 16. Positive 4 is one of the square roots of 16. Alright, so positive 4 is the square root of 16, but also negative 4 is also the square root of negative 16. let me explain just a little bit. When you take the square root of a number, or put it like this, if you do it in reverse, right? If you think about it in reverse, 4 squared, positive 4 squared equals 16, right? And if you do it in reverse here for the negative 4 squared still gives you positive 16. So there are technically 2 numbers that when you multiply them by itself, it gives you 16. So what that means is that when you are finding the square root of a number, please remember that usually there will be 2 results as the square root of a number. So again, guys, when you are taking the square root of a number, there are usually 2 results. There's a positive version and a negative version of the same number. The only exemption to this rule is when we are taking the square root of 0. When you try to take the square root of 0, there's only going to be 1 result. That's because the only number that you get when you try to do that is 0. But again, otherwise, when you're taking or finding the square root of a number, there are usually 2 results.
Pardon the interruption at this time.
So again, when you are taking the square root of a number, you will usually have 2 results, positive and negative. So again, with the number that we showed here, the square root of 16, there were 2 versions of the square root of 16, positive 4 and negative 4. Again, one way you can write that out, instead of writing both numbers, positive 4 and negative 4, instead you can use the plus or minus symbol. So you see here, I've got written, so the square root of 16 equals plus or minus 4. That plus or minus symbol indicates both versions. When you've got that plus or minus symbol, it looks like a plus sign on top of a minus sign, or it might be switched. You may have a minus sign on top of a plus sign. But again, that indicates both versions. That means that both positive 4 and negative 4 are the 2 numbers that we're talking about. So next we're going to talk about writing radicals in its simplest form. A lot of the delta math problems, and I know on your final exam that you're going to take, it's going to more than likely ask you to write your answers or your results in at least the results for radical expressions. They're going to ask you to write them in simplest form, and so we're going to talk about how to do that. So let's say that we're asked to put the square root of 96 in its simplest radical form, or let's say perhaps you just now got finished solving an equation, and your result as of solving that equation was the square root of 96, and again your only option is to write the answer for that radical in its simplest form. So my suggestion is to think of the factors of 96 and think of any factors of 96 that are perfect squares. Remember, we talked about perfect squares, how a perfect square is a number that in other words is a number that's the result of squaring some other number. Alright, so again, if you can think of some factors of 96 that are perfect squares. So let's list out some factors of 96. We've got 1 and 96. We've also got 2 and 48. We've got 3. Oh, I'm sorry, 3 is not a factor there. Actually, it is. We got 3 and 32. We've got 4 and 24. We've got 6 and 16. And we've got 8 and 12. So these are factors of 96. And so if we consider those factors that are perfect squares, so when I look at these here, I do see a few perfect squares. I see here 4, which is a perfect square, because again 4 can be written as 2 squared, right? So 4 is a perfect square, and 16 is also a perfect square, because 16 can be written as 4 squared. So I see those 2 perfect squares. Let me see, do I see any other perfect squares? No, I don't see any other perfect squares. Not that can be written in this form of some number squared. Okay, so once we have considered those perfect square factors of 96, we want to choose the larger or the bigger perfect square factor. We want to choose that group that has the largest perfect square in it. So in this case, that would be 6 and 16. And so when we choose that group, we're going to use these 2 numbers to rewrite this in its simplest radical form. Okay. So once we've got that pair that includes the largest perfect square, the pair of factors 6 and 16, what we're going to do is we're going to rewrite this whole radical. The square root of 96, we're going to rewrite it as, in other words, we're going to split it up into 2 radicals using those 2 factors. So the square root of 96 can be rewritten as the same thing as the square root of 16 times the square root of 6. And my suggestion is to when you split it up like this, to put the larger factor, or not necessarily the largest factor, but when you split it up like this with those 2 numbers, put the perfect square first. So see how here we have the square root of 16, and that comes first. So again, put that perfect square first, the square root of 16, and then put the square root of the other number. And so after we've written it like that and we split it up, one of these square roots simplifies, right? And that was our whole purpose of choosing a perfect square factor, because the square root of 16 is 4, right? So now we're going to actually simplify this. Now we can write this as 4 times the square root of 6. So when we write this, guys, we do not need to use that multiplication dot. The way we write it is like this: 4. Now, guys, this is a big 4. It's not the same as having a little tiny 4 as an index here, sort of written like an exponent. That is not the same thing as having an index of 4. If it was an index of 4, then it would be a 4th root. And I'm going to erase this, but if it was the index 4, it would look like this, a little tiny 4 on the outside of it. And that would be the 4th root. And that would be this type of radical. Again, I'm going to erase that. That's not what we've got here. what we have is 4 times the square root of 6. Oops, let's try that again. 4 times the square root of 6. So guys, this form right here is the simplest form for this radical, the square root of 96. So again, that's how you will put a radical in its simplest form. So again, you will choose factors of that radicand, factors of the number up under the radical. In this case, it was 96. You're going to choose 2 factors of that, or just think about factors of it that are perfect squares. Even if you have to list out the factors, if you can't think of the factors in your head, like I said, you can figure out what numbers divide evenly for that number. Again, 96 divides evenly by 1. It gets divided evenly by 2, divided evenly by all these numbers here. Again, if you can't think of the factors in your head. Next, we're going to talk about something that is probably new for most of you, if not all of you. There are types of numbers called imaginary numbers. I know it sounds like Mr. Starkey is joking around here, like Mr. Starkey, you got imaginary friends, Mr. Starkey, but no, for real, seriously. In the past, you've heard a lot of math teachers, may have referred to numbers as real numbers. There's a reason why they refer to those numbers as real numbers, because there are imaginary numbers. And again, we're going to talk about how exactly it is that we get imaginary numbers, and how to write out those imaginary results when we have that type of situation. So when we're talking about radicals that simplify to imaginary numbers, the first thing that we sort of need to discuss is imaginary numbers, right? So imaginary numbers are directly tied to radicals, to those types of like square roots and things like that. So first off, what we need to realize about imaginary numbers is that you will only have an imaginary number, only have an imaginary number if you are taking the square root of, wait for it, if you are taking the square root of a negative number. So in other words, if your radicand, what's a radicand? The part that's up under the square root. If your radicand is a negative number, if you are taking the square root of a negative number, that is the only time that you're going to get an imaginary number. Okay, so again, you will only get an imaginary number when you take the square root of any negative number. So let's look at a very, very basic concept when we're talking about imaginary numbers. So let's look at the square root of -1. That is, the square root of -1 is equal to, and just work with me here, is equal to I. So folks, I, okay, and I got it kind of written sort of looking italicized because a lot of hopefully that looks like an I to you guys, but again, that is an I. Okay, it's not a J, not a backwards J, or anything like that. It's an I. So the square root of -1 is equal to I, and I is your basic imaginary unit. Okay, so I is the basic imaginary unit, and all imaginary numbers, regardless of what type it is or anything like that, all imaginary numbers are going to have I written with it, and that letter I will let you know that you are dealing with an imaginary number. So again, I is the basic imaginary unit. And again, this is the most basic concept in imaginary numbers. The square root of -1 is equal to I. Alright, so again, all imaginary numbers are written with I. Let's look at a few other things here. So let's say that we were looking at something like the square root of -3. How would we write that? So again, because it's the square root of a negative number, because the radicand is a negative number, we know that this will be an imaginary number, or it is an imaginary number, even if it's not written in that form right now. We know that it is an imaginary number because it is a negative number up under the square root as the radicand. So, so if we rewrite this, okay, what numbers? Well, think about it like this. If we break it down and we rewrite this like this, -1, because we know that factors of -3 are -1 and 3, right? -1 and 3. So up here, I told you guys that the square root of -1 is I, right? So again, this will be rewritten as I times the square root of 3. And again, folks, the plus or minus still applies. The plus or minus still applies to this. Anytime that we take the square root of any number, really. The same way that we'll have plus or minus, and again we had talked about that plus or minus up here. Same way that we'll have plus or minus when we take the square root of a positive number, like the square root of 16 will be plus or minus 4, as in there are two versions of that. It also applies to when we are dealing with imaginary numbers too. Alright, so again, that plus or minus, that is plus or minus I times the square root of 3. Alright, let's look at something like the square root of -9. Okay, so that is the square root of -1 times the square root of 9. Right? So we had said that the square root of 1 is I, right? And we know that the square root of 9 is what? 3. So since this is the square root of 9 is 3, and we have it multiplied times I, we'll write it like that. 3I plus or minus 3I, the square root of -9. Of course, guys, if it was just the square root of 9, it will be plus or minus 3. Okay, I'm going to erase this. So remember, if it was the square root of a positive number, it would just be like the square root of 3 if it was the square root of 9. But since it is the square root of a negative number, again, because that negative is up under the radical, we're going to have to write it with an I. So instead of it just being plus or minus 3, it is plus or minus 3I. Okay? Hopefully that makes sense. I'm erasing this now. Alright, let's look at possibly one more thing here. Really, you've seen one of them. You've really seen all of them. But let's look at something else here. Let's look at something like negative. The square root of negative. Let's do something like the square root of -40. And so again, you may be expected to write imaginary numbers in its simplest form as well, simplest radical form. So again, if we're asked to put the square root of negative 40 in its simplest radical form, or let's say that we were solving an equation and we got the square root of negative 40 as a result, then again what we'd want to do is similar to what we did up here with the square root of negative 3. So again, this is the same thing as the square root of negative 1 times the square root of 40. And so again, the square root of 1 is I, and so that's I times the square root of 40. However, the square root of 40 can be simplified. Remember that we can simplify a radical if we identify those perfect square factors of 40. So think about factors of 40 that might be perfect squares, and pick that pair that has the perfect squares. Pick that pair that has the largest perfect square. And so we're going to do that now. So when we look at the factors of 40 here, and again, if we look at those particular, or look at the pair that has the largest perfect square as a factor, and actually with these we only have one perfect square, and that is 4. So if we pick that pair, the 4 and the 10, and we rewrite it, and let's do that here. Let me move this up. Okay. And so if we rewrite that, we still have to write out the I as well, because that's a part of it. It's imaginary. So that's 4. And remember, we said when you split the radical of 40, or the square root of 40, when you split that up, we said put the perfect square. Put that perfect square first when you split it up into two radicals. So the square root of 4, and then the square root of 10. Alright, so out of those two radicals, only one of them will simplify. Only one of them is a perfect square that will simplify. So the square root of 4, we know that is 2, right? So we already had I times that, so now we'll write this as 2I. Right? Sort of the same way that what we did here with the square root of 9, again, where we put the 3 in front of the I. Okay, so that's what we're doing here. So it's 2I. That's what that part simplifies to, with the square root of 4 and the I. And then still on the inside here, you've got the square root of 10. Okay. Alrighty. So that is how we will simplify, or that's how you'll probably, well, definitely be expected to simplify radicals that involve imaginary numbers. So guys, this was part 1 of solving quadratic equations using square roots. Now, I know we didn't quite get into the solving part, but everything that we discussed here will be used in our solving. So stick around for part 2, okay? I do hope that this was helpful to you guys. I know it was a lot of vocabulary and a lot of different things involved here. But stick around for part 2, where we'll be looking at examples on solving quadratic equations by using square roots. Part 2 up next.